Okay, so this is the second video that I have on how to get the formula for variation of parameters. I have in blue up top written what we used the previous video to figure out. X prime equals AX. It's just the derivative of a fundamental matrix is the same as the original matrix A times the fundamental matrix. Also, the determinant of the fundamental matrix is always non-zero. And what does that mean? That X inverse exists. The next thing I'm going to try and convince you of is that XP can be written as the fundamental matrix times some arbitrary vector V. And that little vector V is going to be the key to our variation of parameters. Also, remember, X prime is AX plus some input, some external force. And then the solution to that is going to be X equals XC plus an XP. Same as undetermined coefficients type things when we had when we weren't in systems, right? We know that this, remember, this is the problem that we're trying to solve. We know that XC for this problem is going to be that right there. And I know that this is the fundamental matrix. This and this are almost just a different way of writing it. This is almost just a different way of writing this. So I know the XC. If I could figure out the XP, then I would know the full solution. Now, what I'm going to try and convince you is that XP can be written like this. So I have a series of, I don't know, 3 or 4 problems that are going to try to convince you of that. So here we go. Here's the fundamental matrix we're working with. I'm going to work out different ways to get different XPs out. In this case, we are working with, we're trying to get this thing, but I'm trying to be an arbitrary, like more the green one here. Like, given any f of t, what would that XP be? How could I get to that XP? So, I'm going to try to convince you that we can get to anything. So, first one, I want you to multiply on the right side. I'm going to have you let v equal this. So you're going to do x times that. So notice I'm just going to copy this x. So e to the negative t, 2e to the negative 6t, e to the negative t, okay, so this multiplication is a little bit different from the square matrix multiplication, but we're going to go across and down in the same way, across and down. Notice if I multiply this e to the t by that e to the, this e to the negative t by that e to the negative t, they cancel out and give me 1. Then the next part, that's this product times that. Next one gives me this times that, which gives me a same thing. The e to the negative 6t and the 6t both cancel out, so I get just plus the coefficient. Same thing works in the bottom. I wind up getting 1 minus 3. And that gives me, well, I'm going to write it. That gives me 3, negative 2. So what I want to point out is that I strategically chose these guys, and I got 3, negative 2. I could have put a 4 here, for example, which would have put a 4 here, and would have multiplied the front row by 4, and would have changed this to a 4, and that to a 4, and it would have given me another number. I could manipulate what I have coefficient-wise here, and get any constant coefficient, right? What would that do? That would help me solve, that would give me the XP for this thing if I had a constant here. So I don't know what the XP would be for that, but I can always get to it by multiplying by a really specific v of t if I could get creative. Like, it's possible. I don't know what it would be each time. So I want you to do a couple more. So I want you to find fundamental matrix times v for this v and for that v. So pause, do that workout. Okay, so hopefully we agree. I got this and that if they're combining like terms. What I want you to see is that if I was asking you to do undetermined coefficients for this problem with a different monkey force right here, right? Then say I gave you something with a sine or a cosine. Well, you would do a1, a2, b1, b2 with the sine and the cosine using undetermined coefficients. What I'm arguing is that I can get to those a1 and a2s if I strategically choose the correct v to multiply by. 10 and 15, 2 and 2 are b1, b2, a1, a2 for a particular input that I would solve for in a particular undetermined coefficients question. Same thing here. I would multiply by this guy to get that guy, and that would be a case where a1, a2 are 0 here and b1, b2. I'm not going to go through all the details, but you could get creative with this and basically get yourself to anything. Why is that? Because this and this are linearly independent. Therefore, I can get to anything. So, bottom line, this becomes a new piece of our box, or like a new thing that I'm going to box that's going to be very important for my variation parameters proof. Okay, so here we go. We are almost there. Remember, I told you this is the formula that I want to get to. I should have you convinced of this, that x prime is now it's correct, that x prime is ax, and maybe I might have had that incorrect earlier, but I don't know. Anyway, x prime is ax, x inverse exists, and xp is big X times some v for some v that we don't really know. If I could solve for v, then I would know a formula for xp. So, and keep in mind, these are all scenarios where I've got x prime equals ax, and remember these are vector x's, plus some f of t. And the solution is going to be x equals xc plus xp. This piece we already know. Remember, it's just from when we did phase plots a long time ago, that xc. So, if I can find this guy, then I then know what the solution is. So, now we're basically, I kept talking about like undetermined coefficients. I'm basically going to do undetermined coefficients here. Well, some of the operations of it. So, what I want you to see is that here I've got x prime, and here, what color do I want to use? I'm going to use black. Here I've got x. So, what I'm arguing is that xp is equal to x times v. Okay? That line is going to replace this x right here. Then I can find xp prime. I can do that by taking the derivative here. What operation do I have right there? Multiplication. Oh, let's use product rule. So what's that? X prime times v plus x times v prime. So this is going to replace that, and this is going to replace that. I guess I should say this part is going to replace. Sorry, I got a little cut off there. I hit the wrong button. Anyway, this right here is going to replace that x, and this right here is going to replace the x prime. Because if I assume this is true, which I think I've convinced you that it maybe should be true, then I could just take the derivatives and plug them in the same way I would do if I were to do undetermined coefficients. So I'll try to keep it color-coded. That gives me x, I'm going to give myself space, x prime times v plus x v prime equals a times x times v plus f of t. I tried to be really careful with colors. Everything in green is exactly the same here. This stuff turned red. This stuff turned black. Now I'm just going to go into just using black. So what's that give me? What's that give me? All right, I got my x prime v, blah, 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 blah. This is the part that I care about. No, sorry. Yes, this is the part that I care about. I specifically care about that. Because look, x prime, x prime. Well, I know that this big x prime can be replaced with an ax. So I'm going to write ax v plus x v prime equals ax v plus f of t. So now look, bam, bam, those guys are exactly the same. So I can subtract them out and they will cancel each other out. And that leaves me with only those two black lines right there. What's that give me? X v prime equals f of t. Well, this comes up to this, this line right here. Well, x inverse exists. What's that mean? That I can multiply on both sides by x inverse. So I'm going to multiply x inverse times x times v. If I do it on the left side, I got to multiply here, f of t. And that gives me, those guys cancel. They give me the identity matrix, identity 2 by 2, which in any, multiply by anything is just going to give it back. So I'm just left with the v. So I get this line right here, that v is equal to x inverse times f of t. Now, I'm going to bring that back up here with this, right? So I know that v is x inverse f of t, and I know that that would be a v right there. So I know that x, xp is x times some v. Well, now look, I've got a formula down here for v in terms of x and the input, that external force, monkey, whatever you want to call it. So what do I get? I'm going to replace this with x, I made a mistake. It's a v prime. What do we do here? Oh, let's integrate, right? So really what I should have in that box is that v is the integral of x inverse times f of t. Sorry, I got a little excited there. So that v is going to be the integral of x inverse times f of t, which gives me my formula xp equals big X times the integral of x inverse times f of t. And notice that is exactly what I have right here. Exactly what I have right here that I wrote in the beginning of the previous video this right here is my formula for variation of parameters. And once again, with all the things that I teach you, like I could have just told you that, right? And you'd be like, okay, right? But I really, really, really think it's important for you to see and be convinced that that has to be true, to see how it works, to see this math, right? And to be convinced, yeah, you know, I agree with that. You may not, I don't need you to reproduce this on a test ever, right? But you should have understood all these steps, and you should have understood all my little like arguments here in blue, right? Like, yeah, they all make sense well enough, right? And where does that lead us? It leads us down to here, which gets us to our variation of parameters. I think the next video will be an actual example because like I haven't really done any numbers yet. But there you go. That's variation of parameters. I hope it makes sense to you.